Electron is vertical on the pad, operators are on console in mission control, and the range has been cleared at Launch Complex 1. You know what that means? It is a Rocket Lab launch day for our next Electron mission. My name is Muriel, and we are just 16 minutes or so away from liftoff with a dedicated mission for Japan-based Earth observation company iQPS. And 2025 has been our busiest launch year yet. And while we've been saying that pretty much every year since launches began in 2017, that is because we've beaten our own launch annual record every year since. In 2024, we hit 16 launches, and now in 2025, with today's mission, we're about to take that tally to 21. On board Electron today is a single synthetic aperture radar satellite called QPS SAR-15, nicknamed SUKUNAMI-I for the Japanese god of great wisdom. And with that in mind, we have called this mission the Wisdom God Guides, to follow the launch naming convention that iQPS has followed for all 6 of their missions so far on Electron. Now, SUKUNAMI-I is destined for a 575-kilometre circular Earth orbit, where it will provide near real-time observation of Earth. But unlike Earth observation satellites with optical sensors, SAR, or synthetic aperture radar, can see through clouds and provide imagery day or night to provide uninterrupted views. And this makes SAR data particularly useful for monitoring natural disasters, identifying and tracking changes such as ice or vegetation movement, mapping terrain, and a whole lot more. And today's mission will be our 7th for iQPS since our first launch for them in December 2023. And each launch name is a nod to the deity that the satellite on board is named after. And so far, we have had the moon god awakens, the lightning god rains, the sea god sees, the mountain god guards, the harvest god thrives, the nation god navigates, and of course, today's mission, the wisdom god guides. Now, while we prepare to go to space for iQPS again, let's check out the highlights from those previous missions.
2, 1, liftoff.
3, 2, 1.
3, 2, 1, liftoff.
We have certainly delivered some beautiful launches for iQPS, and it's going to be good to add another one to the books tonight. And we are just 13 minutes away from liftoff, which means our operators are preparing to run through the go, no-go poll. And this status check starts at T-minus 12 minutes and includes operators in mission and range control reporting into the launch director whether the system that they are responsible for is green for launch. Now, obviously, what we want to hear is greens across the board, so let's listen into mission control to hear if that's what we get.
And to all operators, LD and mission code, we are proceeding now with the go no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Vcon.
Vcon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
LD sub.
LD sub is go.
The go-no-go sequence is complete. We are currently T-minus 11 minutes and 22 seconds and counting. We are go for terminal count auto sequence at T-minus 10 minutes. From this time, the freeware procedure is in effect.
That's a definitive go from today's poll, and at T-minus 11 minutes or so, we are moving ahead through the final few moments before launch. Our operators are ready, Electron is ready, so is the range, and the weather for liftoff tonight is 85% favourable for an on-time launch at 7:36 p.m. local time. The journey from Earth to orbit on Electron takes around 9 minutes, starting with ignition of the 9 Rutherford engines on Electron's first stage. At T+0, the hold-down clamps on the launch mount release the rocket for launch, and within seconds of its ascent, it begins its pitch-over maneuver, which you'll hear operators call out from mission control. And this directs Electron away from the launch site and sets it on its desired trajectory. Now, around a minute into launch, we will reach max Q, the moment when Electron experiences the highest loads on its way to space. And altogether, we have an engine burn time for those 9 Rutherford engines of around 2.5 minutes before they are shut down, just seconds ahead of stage separation. Next, after those first and second stages separate, the single Rutherford engine on stage 2 will ignite to continue the rest of the way to orbit. And along the way, the fairing will separate too to expose the payload to space ready for deployment before finally, at around 9 minutes after lifting off from the pad, Electron's second stage will reach orbital velocity. And that is when the kick stage will separate, with the payload still attached, ready for a roughly 40-minute coast phase around the Earth in an elliptical orbit. And once the kick stage has completed that coast phase, the Curie engine will perform a final burn to circularize the orbit ahead of payload deployment. Simple as that, but of course, in reality, it is anything but. And producing one orbital class launch vehicle is a significant feat, but doing it more than 70 times makes Electron one of the most prolific rockets in the industry. And behind that effort are many, many talented and dedicated people like vehicle integration technicians, development and manufacturing engineers, software engineers, launch technicians, mission managers, licensing and launch safety teams, composite technicians, test engineers, GNC engineers, and of course, a whole lot more. And these are the people behind Electron and across all our programs and products. We have open roles in most locations right now too, so if you want to join them, check out the careers page on our website, rocketlabcorp.com.
Proceed with sequence 60, stage terminal checks.
Copy your mic.
GC alien mission code.
LDGC.
Please proceed with sequence 61, launch pad ready.
Copy sequence. 61 on work.
Stage 1 and 2 high voltage batteries ready for flight.
Okay, a T-minus 7 minutes, 44 seconds on the clock now, and there have been no red flags in the countdown to liftoff. The iQPS SAR-15 SUKUNAMI-I satellite is ready for launch inside Electron's fairing. And who better to tell us about the spacecraft's mission than the iQPS team themselves? So here's more about what SUKUNAMI-I will be getting up to on orbit.
Founded in Fukuoka with the mission of establishing a space industry in Kyushu, iQPS marks its 20th anniversary in 2025. Today, together with more than 25 partner companies, mainly based in northern Kyushu, we are developing the world-class small SAR satellite, QPS-SAR. SAR satellites use radio waves, enabling observation of the Earth's surface day or night in any weather. iQPS is steadily working toward a 36-satellite QPS-SAR constellation, aiming for near real-time Earth observation almost anywhere on the globe. Since launching our first satellite in December 2019, we have continued to expand our fleet and gained extensive expertise in operations. In March 2025, our new R&D hub, QSIP, was established. QSIP integrates manufacturing, testing, and shipping on one floor, enabling production of up to 10 satellites per year. This boosts efficiency and development speed, accelerating launches and service readiness. Partnering with government agencies, infrastructure operators, and others, we are already delivering results by combining satellite data with image analysis and AI. Our satellites are used for inspecting large infrastructure and monitoring wildfires, earthquakes, eruptions, and other disasters, helping detect crises early. As natural disasters and geopolitical risks increase worldwide, the need for our high-precision observation data grows more urgent every day. Faster, more accurate, covering more places than ever before. We will continue expanding our constellation, realizing a world where Earth is observed more frequently. Unlocking the potential of space and contributing to human progress. The challenge of iQPS continues.
Okay, we are heading into the final few minutes before liftoff from Launch Complex 1. The weather remains green and all signs are pointing to an on-time launch this evening at 7:36 p.m. local time here in New Zealand. From T-minus 2 minutes, Electron's autonomous flight computer will take over from the operators to run the final 2 minutes of pre-launch checks itself. At any point during this process, the flight computer can hold the launch if it assesses that data warrants some closer inspection. But otherwise, from T-minus 10 seconds, you'll hear the voice of our launch director counting down from 10 before liftoff for the Wisdom God Guides. Now that auto sequence is about to start, so let's listen into the operators in mission control as they share their final call-outs ahead of launch. Go iQPS and go Electron.
To all operators, LD on mission code. From now on there should be no red flags on your critical LCCs. Beacon LD on mission code.
LD beacon.
Please lock the auto sequence and confirm.
Locked.
And Beacon, please confirm all flight computer ASCOs are green.
All flight computer ASCOs are green.
To all operators, we are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
Vehicle is fully on internal power. AFTS is green and enabled for flight.
LOX load is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Click on.
Beginning picture.
Stage 1 propulsion nominal.
We are on our way to space for iQPS again with a nice clean launch from the pad from Launch Complex 1. And Max Q is the first milestone that we'll come across, which is that point in flight where Electron faces the toughest atmospheric forces. To accommodate, the Rutherford engines will throttle down just a touch before they're brought back up to full power to continue the mission. Let's listen in.
Approaching max Q. Cleared max Q.
And like clockwork, there is the call that Electron has successfully passed through max Q. And those Rutherford engines are burning bright and beautiful on your screen as Electron makes its way more than 21 kilometers above Earth at more than 2,000 kilometers per hour. And we are only 60 seconds or so away from Stage 2's time to shine as we approach MECO, or main engine cutoff. And MECO is the point in flight in which Electron's 9 first-stage Rutherford engines shut down in preparation for that stage separation. Now, with its role in the mission complete, the first stage will be jettisoned, and then it's all about the second stage and its single Rutherford engine that will ignite to keep the mission moving. And there are just seconds between Stage 1 engine throttle down, MECO, stage separation, and then second stage ignition. So let's listen into the operators in mission control now as they call out those events in real time.
15 seconds to staging.
Enter it burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
Stage 2 guidance is knocked on.
That is MECO complete and a nice clean stage separation, and the second stage's Rutherford engine is accelerating nicely now to take us almost past, there it is, 100 kilometers above Earth. And in the meantime, the fairing's important job of protecting the QPS SAR-15 satellite through the initial launch phase is almost complete. So once we reach around 135 kilometers in altitude, the spacecraft can be exposed to space in preparation for deployment, so those two halves of Electron's fairing will separate and fall away.
Fairing jettison confirmed.
That's what we like to hear and see. Fairing separation is confirmed. And now at T plus 3 minutes 45 seconds into flight for the Wisdom God guides as Electron passes more than 8,000 kilometers an hour in speed. And hello, of course, to QPS SAR 15 on your screen there, safely integrated to the kick stage on top of the second stage as it continues on to our 575 kilometer target orbit. We've got 6.5 minutes or so of engine burn time for this Stage 2 Rutherford, and along the way we will reach Electron's next mission milestone, battery hot swap. That is scheduled to take place at T plus 6 minutes 30 seconds. Now, the reason Electron performs its unique battery hot swap maneuver comes down to the Rutherford engine. They don't have a traditional gas turbine. Instead, their fuel pumps are powered by brushless DC electric motors, and powering those pumps are batteries. The engineers in our team realised there's no need to carry the mass of depleted batteries all the way to orbit when we can use that mass for payload instead. So they came up with a way of getting rid of those empty batteries and swapping them out mid-flight for a new set. And that process is coming up next.
Guidance nominal, 200 seconds remaining.
HVB discharge nominal, approaching hot swap in roughly 30 seconds.
Battery jettison confirmed.
Hot swap successful.
There we go. That is a successful hot swap, and Electron's second stage continues on to orbit with a fresh set of batteries to power Rutherford's fuel pumps. Now, these pumps give us really great control over engine throttle capability that enables us to squeeze every drop of performance out of every drop of fuel, and that is very important on a small rocket with limited fuel margins. Electron is now traveling at more than 16,000 kilometers per hour, just about to hit 250 kilometers above Earth, with engine burn scheduled to end at around T plus 9 minutes and 9 seconds into flight. So before long, it will be time for SECO, or second engine cutoff, which is the moment in flight where the Rutherford shuts down in preparation for kickstage separation. Now, the mission is proceeding nominally, so let's just enjoy these views of Rutherford powering us all the way to orbit. Just a couple of minutes left in this burn until we hear that call out that Electron's second stage engine will throttle down in preparation for shutdown, or SECO. Now, that bright orange engine nozzle you see on screen will shortly turn grey as it cools down rapidly in the cold of space. And this is our visual sign that the second stage burn is complete. But we'll also hear the call out from Mission Control that we have had SECO and kick stage separation. That's our audio confirmation that this primary phase of the mission is complete ahead of the kick stage's coast phase. So let's listen in for it.
20 seconds remaining.
Seco confirmed.
Nominal transfer orbit achieved.
Stage separation confirmed.
Second engine cut off complete, and the kick stage has cleanly separated as planned. So with that, we are successfully in orbit, and the job is done for Electron's first and second stages, but now it's all over to the kick stage, which will coast around Earth for about 35 minutes or so before firing up its 3D printed Curie engine to circularize the orbit for iQPS's spacecraft ahead of deployment. Now that is scheduled to take place at around T plus 46 minutes into the mission, so take a break, sit back and relax while the kick stage takes a scenic tour of our planet, and we're going to do the same, but we'll see you back here in the next 35. Welcome back to the launch of the Wisdom God Guides, Rocket Lab's 21st mission this year and our 79th launch overall since Electron first took to the skies. Now, Electron lifted off from Launch Complex 1 Pad B at 7:36 p.m. today and progressed nominally through all the mission milestones so far. All that remains is to finish off a Curie engine burn on the kick stage that will circularize our orbit, shortly followed by payload deployment. And at that point, iQPS's satellite will be in its new home in low Earth orbit, ready to provide SAR data back to its users on Earth. Now, Curie ignition occurred during our coast phase, and we are just waiting now for the successful engine shutdown. So let's listen in to the operators in mission control to hear the call.
Curie propulsion nominal. Curie cutoff confirmed.
Thank you, Curie. And with that, the kick stage's orbit has been circularized. So all that remains now is payload deployment. And we're waiting to hear those two magic words from mission control: payload deployed. Bring up those audio channels now and listen in.
Payload QPS SAR-15 separation confirmed.
Welcome to orbit, SUKUNAMI-I, and welcome to space again to the iQPS team. The Wisdom God has joined its compatriots in space for the QPS SAR constellation. And for the 21st time this year, Electron has delivered 100% mission success. Congratulations to our customers, to the Rocket Lab build and launch teams, and of course, a very big thank you to you at home for sharing the experience with us. Whether this was your first Rocket Lab launch or your 21st this year, we are honoured to have you join us. We wish you a very happy holidays this festive season, and for the 7th time for iQPS, 21st time this year and 79th time overall, this is Rocket Lab Mission Control signing off.